Hi guys, for Honors Algebra 2, this is Miss Craft. We're doing lesson 17 today, in our last week before finals. So, today we're going to be talking about projectile motion. So this just continues our quadratics unit, and kind of closes it up for the semester. All right, in the previous classes you should have learned some factoring, and you should have learned the quadratic formula. In both cases, we're going to use them today. So when we're solving real life problems using the quadratic formula, we can talk about something like projectile motion. This is just an excerpt from you guys' book. We have a function that is h equals negative 16t squared plus h naught. So whenever you see like a variable with a sub-zero, it's pronounced naught. So it's negative 16t squared plus h naught. And usually what this naught means is that it's initial. Okay, so it's always going to mean initial. So in this case, it's initial height. Okay, and then you're going to see it down here when we have the variable v, and we have v naught, and that means initial, and it's initial velocity. Okay, so just make sure you keep that in mind. We'll use that throughout our course next semester too. So basically what this means is that we can use this function to predict the time that it will take an object to reach the ground or to reach a certain height. So for an object that is launched or thrown, an extra term v sub naught times t, which is time, must be added to the model to account for the object's initial vertical velocity in feet per second. So all of the problems we're going to do in this class are in feet per second. So just make sure that if you're applying this outside of these situations, that you have your units in feet per second. Recall that h is the height in feet, t is the time in motion in seconds, and h naught is the initial height in feet. So if something is dropped, we use this. Basically, this negative 16t squared accounts for gravity, okay? And so when we have something that is just dropped from the sky or from the air, or it is going at, I mean, this kind of uses the bow and arrow, but I don't know that I necessarily agree with that. Or when we talk about, we have some problems where it like drops off of a cliff, that would be a zero initial velocity. Okay, so for this one, for the other option, we have this v naught times t, and that's just the middle part of our quadratic, and that's what adds the velocity of the force going downwards or the force going upwards. Okay, so obviously we'd have a negative force here, and we'd have a positive force here. Okay, so take any of those notes and pause me as you need to. All right, when we're talking about this guy, oh, I have a juggler on my face. A juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial velocity of negative 30 feet per second. So again, I would just, as you're doing these, I would just write your equation up here, plus h naught equals the height at the end, right? So we would say the ball leaves the juggler's hand. Well, that's the initial height is 4. The vertical velocity, oh, that's v naught, and that's 30. And he catches the ball when it falls back to a height of 3. So that's the ending height, and that's 3. Okay, so then we just plug this in. Negative 16t squared plus 30t plus 4 equals 3. Okay, and now we want to use the quadratic formula because I don't want to factor this guy. So you can always try to do that first if you'd like to, but the quadratic formula works just as easy. So we'll subtract the 3 over here, so it'll give us a plus 1. So we need to have it in ax squared plus bx plus c, right, in order to put it in our quadratic formula. When you go to your quadratic formula, it's going to be the opposite of b, right? Plus or minus the square root of b squared minus 4 times a times c all over 2 times A. So you can literally put this in your calculator. I'm going to show you guys on this one how to put it in your calculator, but you don't necessarily, I don't think you're going to need me to actually show this to you every time. So just go ahead and pause me once you've written the problem down and you're ready to carry on, because then I will just start right from where you left off. So we have negative 30 plus the square root of 30 squared minus, and then I always put this in parentheses, 4 times negative 16 times 1. Okay, and then you can either start off by putting these in parentheses, or you can push enter and then do divided by negative 32. And we get a negative. Now, does it make sense to have a negative time when we're talking about how long it takes the ball to reach back to our hands? No. So we would plug this in the opposite way, right? Minus the square root of 30 squared minus 4 times A times C divided by negative 32. And we get 1.91 seconds. Okay, so then you just go 1.91 seconds. Okay, so this, if you can imagine this is like a parabola here. We let go of the ball up here, and we're trying to see when it lands back down here. So of course, one of these is not going to make sense, because in a real life situation, one end will likely not make sense. There is cases when both of them will, but for this one, we want to know the positive value over here. Okay, so 1.91 seconds. All right, Nora hits a softball straight up at a speed of 120 feet per second. So we are going to use that as our initial velocity of 120 feet per second. Her bat contacts the ball at a height of, so her initial height, right, is 3 feet above the ground. How long will it take for the ball, if in the air, how long will it be in the air if no one catches it? So we can assume that our ending height is 0. Okay, so we'll go ahead and plug this guy in, and it turns into negative 16t squared plus 120t plus 3 equals 0. Okay, and you can go ahead and plug that into the quadratic formula, which I will write down for you right here. We'll say negative 120 plus or minus the square root of 120 squared minus 4 times negative 16 times 3. And all of that is over 2 times negative 16. Okay, I'll give you a second. Make sure you know how to plug that into your calculator. Pause me if you need to. And then I got 2 answers here. One was negative 0.0236 approximately, right? Approximately, not exactly. And then the other answer is 7.52. So of course 7.52 is going to be the real life answer for how long it took the ball to hit the ground. Okay, and then one thing that you can change about this, what if the outfielder catches it at a height of 5 feet above the ground? Well, in that case, then we would just use our same exact equation, right? She hit it just as hard. And she hit it at 3 feet, but then it landed at 5 feet. So if someone caught it up in the air at 5 feet high, how long would that take? So for this one, of course, you'd want to move that 5 over to the other side, and you'd have negative 2 equals 0. Plug that into the quadratic formula and see how that comes out. So if you're thinking about that in a real life situation, it should be less time than 7.52 seconds, right? All right, so a golfer is teeing off at par 8 on a par 8 hole. The ball leaves with a velocity of 18 feet per second. So that's our initial velocity is 18 feet per second. It's a hole in one. So when the when will the ball land in the hole? So we're going to assume that the height is at 0, even though the hole is usually a little bit lower than 0, okay? And when we think about golfing, the ball probably left at a height of 0, right? So we've got a bunch of zeros in here. So we can just plug them in. Negative 16t squared plus 18t plus 0 equals 0. Okay, so this one actually is a little bit easier, and we don't have to use the quadratic formula. We can say, well, I just want to factor out the greatest common term here. And so what I did is I pulled out a negative 2t, and that leaves me with 8t plus minus 9 equals 0. Now it's really easy for me to do zero product property and figure out that, well, t is 0 when it left the ground, right? That's our parabola. It was 0 when it left when we were golfing, and then it landed over here. And where did it land? Well, it landed when t was equal to 9/8, which is approximately 1.125 seconds. That's how long it took for the ball to land in the hole in one. Okay? All right, we are going to do this problem last. So a pilot of a helicopter plans to release a bucket of water on a forest fire. The water is released from an altitude of 500 feet. So that would be our initial height is 500 feet. Because it's being dropped, it doesn't have an initial velocity. How long will it take for the water to reach the treetops 20 feet above the ground? So we're going to end at 20 feet. Okay, so here we can plug it in, negative 16t squared. We don't have this guy, but we do know that it started here at 500 and landed at 20. Please use square roots to solve this. I think it's way easier, and you don't have to plug in a 0 for b. So if you solve this using square roots, we can just subtract 500 from one side. And now we have negative 16t squared equals negative 480, right? And then when we divide by negative 16, we get t squared equals 30. And then, of course, the square root of both sides is t equals plus or minus the square root of 30. The square root of 30 is approximately 5.48. Okay? So obviously, we only want the positive answer here. And so we can go ahead and erase our negative answer in there. So it takes 5.48 seconds until that water is going to hit the top of the trees. If you guys have questions about these, we're going to do lots of examples in class if needed. Please write them down and ask your teacher. Go back and try these without looking at my work, and then try and see if you got the right answer. And we will see you in synchronous learning.